Thank you. My dear students, it's our practical class number 9, Introduction to the Major. You do remember. No practical task for you this time, because it will be continuation about design, and as we have been previously in subject of helicopters, about rotorcraft. Previous class was about all about rotorcraft, not about helicopters. And I hope you do remember that not only helicopters considered like rotorcraft, at least autogyres and gyrodynes. The difference is that autogyre has not driven main rotor, it's just auto rotation due to relative winds that appear while linear motion of autogyre. So autogyre has engine for cruise flight and main rotor only on auto rotation. There are a couple of another name for autogyres, so it doesn't matter. Gyrodynes, it's such heavy hybrid between airplane and helicopter, because they have both driven main rotors and cruise engines. While cruise flight, they use cruise flight engines, and their takeoff and landing may be completely vertically due to those main rotors. No, and quite clear that gyrodynes, however popular they were at their period, they are overweighted. They are too heavy, and due to this, of course, their maintenance will be not economical, rational, not feasible. But idea was interested, and I should say that a vertical takeoff behind of obsession of some person like them, Sikorsky, Yuriev, and other people like Говард Hughes, maybe, besides of their extreme interest to exactly to the vertical takeoff and landing, people have various needs to such takeoff and landing. What we're going to talk about right now about the airplanes of vertical takeoff and landing and short takeoff and landing. I have found, no, as typically, I have found for you some books additionally, and in case you will be interested in subject, you open and watch it. If not, no, I propose you to save it. Maybe once these books will be useful for you. And some of these books, they are literally for entertaining, like richly illustrated with some historical short information, some short data. Some of those books, they are more serious. In particular, the books that I sent, no, now it's open twice in different places. I will not try to move it right now because I prepared to show you things. The book, which is called Fundamentals, how it's called? Let's see. One of the last. Fundamentals of Aircraft and Airship Design, Volume 1st. If I find continuation, I'll be quite happy about. Very interesting book, and contain a lot of practical data, statistical data, very useful for you anyway. Let's remove everything we don't need, and to start to inspire your interest, we will start with not these great diagrams. I will show you something, and next we will try to understand what it's about. Well, first, it's already somewhere opened. It's linked in. Here is done. And I propose you to watch such a short video. Extremely short, and of course you already have noticed what has happened here. Seems like we have normal airplane, but this normal, quite normal, conventional airplane is hovering in air. Landing and hovering and landing in the air. How? No, one of the things is you already see. And by the way, pay attention to that place. That place is also interesting. It's not shown in the movie, but do pay attention to the fact that here is some some cover that move up, and at the bottom also it has something interesting that moves under the airplane. So this thing was shown for us, but what is inside of airplane, it was not shown, but certainly it's also something interesting. Well, that one is so-called vector thrust. You already maybe seen such things, and you at least may read already what is written here. Wait a second. It's disappeared. Oh, yolki-palki. Sorry. Wait a second. Here is. Here is. No. And right now we see the same. Not the same. It's twin-engine airplane. Do not remember which one. But you certainly see it's so-called controlled thrust vector. How to apply? Okay, stay like this. As usually. It's thrust vector control. In English, it's this abbreviation exists like TVC. TVC. We may call it, of course, controlled thrust vector that is controlled, but the abbreviation TVC you may find in internet. No, what do we see at all? It's quite normal for jet exhaust channel that it's changeable in the shape. It's help to change. No, changing of this duct may regulate the speed at the exit of this exhaust speed of the airplane, and due to this it will be a different amount of thrust. Also different energy of the stream from engine, but do pay attention that they are changed in direction, and moreover they may independently change in direction. What it may be resulted in? No, one of the options that this thing is able to short take off, or maybe to take off vertically at all, as we have seen in previous video. But at least this thrust vector control, it's give you opportunity, besides of takeoff and landing, it's give you opportunity of higher maneuverability. Of course, it's not important for passengers or cargo airplanes. It's important mostly for military airplanes, quite clear. And when we use flight controls, of conventional type of flight controls, these deviated surfaces, declined surfaces on the at the trailing edges of wings, stabilizers and fin, that is a little bit slow flight control. That on supersonic speeds, of course, it's not so. No, and in battle engagement, so-called air engage between airplanes, it's also rather slow. And you understand that who is quicker, that one have more chances in such engage in such a battle in air. Who is quicker, who is more maneuverable, and so many companies all over the world, they've been involved in such a work, and that is one of early design decisions of thrust vector engine exhaust. To forgive me what I see. I touched that one. No, not much maybe interested. And the most obvious answer, as I said, for vertical takeoff and landing. No, here is it's not quite the same decision. And by the word, do pay attention in that video that I said. Should we move it once again to compare the scheme we see? And the video. Давайте please. And pay attention. Here is it's shown. No, it's shown for Yakovlev airplane. This scheme, very popular picture in internet. You may find it everywhere. And what is given here? That it has engine inside, and this engine, you see, it has, oh, I hope you already understood, it has 3 exits. Look at this. It has, well, one normal exit, not normal, we get used to see. It's so-called exhaust channel of engine. And this exhaust channel, it's controllable, it's rotatable, movable. It's may direct thrust in another direction instead of jet stream. It's may direct, not thrust, but jet stream. Jet stream, that directed backward to the airplane. Now it's directed downward with respect to the airplane in this scheme. Moreover, to pay attention, it has 2 more additional channels that go through the wings, and certainly they also directed downward. And here is that interesting moment that I said, do pay attention, something happened here either. It's so-called additional fan. Whether this fan driven immediately from this engine or it's some another source of energy, right now it's not important. Important is that you may use additionally, here is something like ducted probe inside of the airplane immediately behind of the cockpit in the airplane, and this thing also create you additional force directed down that you may use during takeoff and landing. No, once again, if we click this to repeat, what here is the opener place, the opener cover over the fan, and fan is working, and now everything is closed. That's it. It's already used the engine in normal cruise position. Well, that one maybe we don't need any longer. We may close it. If necessary, we will find it anyway. And let's continue here. Now, of course, it's, I'm already said you, it's for maneuverability. And now we see the same airplane, what scheme of this airplane, the real one. We have seen it in the in the operating already. No, and there are different variants of design decisions. You have seen already one of them. That is impressive demonstration of another one. Engine with TCL thrust control vector, thrust vector control, it's called. And quite clear that such airplanes, they are able, they have property which is called super maneuverability. They are not just maneuverable, but super maneuverable. It's normal term in Western countries, no, and in our country also, but in another language. But there is super maneuverability. And what is super maneuverability? It's necessary. I'm already said you. It's necessary in the battle above the all. And no, next, it was a story here about in my channel. I mean, I make notes about the. It's called Cobra Pugacheva. It's in English also called Cobra Pugachev, Pugachev's Cobra, and no, after the pilot who first has accomplished it in the air. Impressive, you see, it's practically. No, we understand that in this position it should just fall down. It's not able to continue flight, but it's continue the flight. And why I wrote this story at all? Because this effect that pilot accomplished in the flight. Really, it was beforehand, it was completely calculated and even tested in RC models, radio controlled models. Moreover, as I was said by those who tested it 30 and something years ago, one of our scientific institutions of our university, they said, we have found this effect occasionally. We didn't meant to do something like this. And here is, you see the name. Scientific institution of problem of physical simulation, actually supposed to be called. And you see a model of this airplane, RC model, being used for testing and so on. Now, after I boasting a bit with our university, history, let's come back to this story about vertical takeoff and landing and short takeoff and landing. Now, maybe the simplest will be to remember about time. I do not remember the time again. Okay, let's think that I'm talking already for 10 minutes. For 40, and it means by 12. Great. And as only I do not write down the time, you will suffer more than usual. Do forgive me, because I over time again. Let's come back to the story about short takeoff and landing and vertical takeoff and landing. Now, super maneuverability you has already understood. It's one of the advantages, let it be, of this, one of the way to solve problem of vertical takeoff and landing. That is something like additional option has appeared due to this attempt to understand how to take off and landing vertical. First, let's talk about abbreviation which is called STOL. CTOL. It's short takeoff and landing, and next one it will be vertical takeoff and landing. What in this speech it's good visible for you. Vertical takeoff and landing. No, as it said in this book, there is no clear understanding what should be called short takeoff and landing. Usually, it comes about not absolute values, I should say. It comes about percentage of reducing the need in runway, reducing in takeoff and landing runway of the airplane. In comparing to the airplanes of the same class, let it be. And usually when people talk about this short takeoff and landing, about this CTO aircraft, they show the airplanes of not general aviation, but airplanes of passenger class, airplanes of agricultural class, and airplanes of so-called light class. It means that they are for passengers up to 10 passengers, for instance. I may show you the list of these airplanes, like we're showing quickly the photos, and you will see that mostly it comes about the little airplanes, so comparatively little airplanes. But there are some airplanes, and it's already considered like some outstanding achievements, which realize this short takeoff and which realizes this STOL concept in rather heavy weight. And among of these airplanes, our Antonov 72 and Antonov 74. And it was great surprise for me around 20 years ago to find out that we've been said, usually when we were students, we've been said that effect command using, it's our unique achievement, and so on and so forth. And once I have seen the video, very similar to our Antonov. Let me to show you Antonov. I prepared here the special photo of Antonov. Такое вау фото. We've been said that this airplane is unique, and I see seems like Antonov, but little bit different. And I was greatly surprised to understand, to know that it was Boeing airplane, that additionally it was designed some similar things with another companies, and interesting that everything was designed at approximately at the same time. No, story similar to the competition between Tupolev supersonic 144 and European Concorde and supersonic passenger Boeing, but which been stopped on time, let's say, in order not to waste money any longer. And what we see right now, what is idea of this short takeoff and landing without additional tricks, let's say, without all these tricks that we will see in vertical takeoff and landing. No, above the all, of course, it comes about super efficient high lift devices. It means that what what only possible, especially for takeoff, what only possible to change, to pay attention what happened to the wing. I've been searching for this photo on purpose to show you. No, that we see it during takeoff, that is why spoilers also moved up. And besides of spoilers, what happens to the engines? Is it some vertical direction of thrust now of jet stream? No, it's so-called reversed engine. Reversed engine thrust. Also, I maybe will find for you in my channel right now to show it. And that is for effective braking, of course. As they take off, this reverse covers, they will close it tightly because we need all our thrust for realizing takeoff. And here thrust is directed to another side, as you might see. Let's try to see reversed thrust. Vectored thrust, reversed. I have it somewhere. Oh, here is. Yes. The whole story about, you see. And here is photo once again of Antonov 72. Maybe practically the same landing. No, actually I took it like screenshot, you see, but in another racourse. And seems like airplane is broken, yes, but really it's not, and we already understand it. And it's not the only airplane. No, that is, you see, the same airplane Antonov, but another, not another configuration, another suit, as it's called. It's for military airplane, maybe. Also, we see a reverse of engine, and here is another airplane, 4-in-1. Not clearly remember which one. But certainly it's 4-in-1, and we see this device of engine reverse, but realize it in another design. And also we see in a wing, I hope it's visible. Da, do pay attention, those high-lift devices, how they are significantly changed, how they deviated. Well, and no, about the engine reverse, I hope it's clear. How it's maybe changed in direction, whether to some sides or to the one side. It may be realized in different design. And just again, like to entertain you, that airplane that we have seen. Why will you move, Your Highnessy? Yes, impressive, a bit funny. And it's not big airplane. To pay attention, illuminators, it's something little, rather little, and this this device, it's necessary to shorten its landing runway. Very well. No, that is about, as I already said, you reversed engine and thrust controlled engine. Yes. It's Tornado airplane, American, as it's written in my own notes. And we will see now one more effect. Да. Oh, this engineering decision rather similar to what we have seen into another airplanes. You see, what foreign decisions look like this mostly. Our decision, it's one roof moved up. Here is the same Tornado, but in no, during runway on landing, you see engine exhaust was redirected. What, and on the flight. Well, that one I will clean. And what else may be used? No, above the all, high-lift devices. And these high-lift devices, they are maybe of different types, so-called Fowler flaps in some sections, in some chains, let's say, one by one, to increase the surface of area, to increase area of wing surface, to change curvature, in order to control, to change significantly the coefficient ratio of lift. And one more interesting effect that may be used to pay attention to this interesting picture. It's so-called Kanda effect. This Kanda effect we have seen even in movie and short movies. When we're talking about the Bernoulli principles, we have seen like children play with the light ball and fan. Children, adult people, how they control the light ball, how they hover it in the air in their fan jet stream, and moreover they control it. They move, change its position due to redirection of the stream. But seems like this jet, it's adgathered, jet, do forgive me, this ball, this little ball is adgathered to the jet stream. Instead of fall down, it's just glue it up and get it to the stream. That is so-called Kanda effect. When you study aerodynamics, maybe you will already have been studied this effect of Kanda, and what this, how this effect, Kanda effect, may be used in structure. No, typically it's by the placing the engine under the wing and over the wing. This decision with engine over the wing we just have seen, it was here, not here. It was here. Yes. Engine is over the wing, and during all the flight, and especially during takeoff, the additional the addition to the velocity at the root of wing is created due to the engine exhaust blow out the air from the wing, and due to this it's supposed to create additional lift in this case. It may be designed on the wing and may be designed under the wing. You see different concepts, powered lift stall concepts, as you might see. And as I already said, it was realized in some airplanes, and among them, this airplane, but Boeing experimental plane. Let me do, I have even prepared it here. No, not here. I made it like this. That thing I've been laughing about. Look at this. May you, from the first glance, may you distinguish who is who? If we have no different notes where it was. But for instance, it's written here Boeing YC-14, but it's not Boeing, it's our Antonov. That is Antonov, that is Boeing. Extremely similar to each other, practically the same decision, high wing engines, jet engines, turbojet on the wing, T-shaped stabilizer, and so on. Difference is very little, but it doesn't mean that someone stole the design and act like by prototype, because practically at the same time they have made in flights, maybe with difference. I've checked it on internet, of course, after I noticed this interesting moment. And made in flight was made with difference around half of year. You understand maybe that if design of airplane lasted for 5-7 years, even now, and 40 years ago, because it's middle of 17th, 40 years ago, it was even worse in this meaning, because we have no computers, we did everything. We had computers, but not like this. Maybe you may see something in old movies, because I trust you never seen such things. I've been working with such computers 35 years ago. I know what I'm talking about. You may see it in a movie, maybe. And these huge wardrobes, let's say, with primitive devices for input of data and output of data, if even they was already with screen, the input of data may be realized via so-called hard carriers, so something like card, the perforated cards, perforated strips, and so on, not even from keyboard. And those computers were not able they were not used for creating of 3D models. It was not practical, it was not able then. They been using them for some calculations, for calculations of for numerical calculations by mathematical models that developed by scientists, and they may be of theoretical like models, they may be with equations, I mean, and they may be numerical models, but these numerical calculations, they took weeks literally, in contrary to some hours or some minutes even, how it's maybe in modern computers, it comes about weeks of calculations for each particular case. And quite clear that computers not much been in used for creating of airplanes. So creating of airplanes was approximately 1.5 longer than it's maybe now. It's only about design. I'm not talking already about manufacturing and moreover about serial manufacturing. I'm talking now only about design process of aircraft. Do forgive me once again about Kanda effect been using over the wing and under the wing. I hope you already understood. No, at least you will take it into your account, into consideration. And additional tricks that might be, I haven't found much photos about, but we may read about them in the literature. Additional devices that serve for increasing takeoff, for increasing the lift during takeoff and landing, maybe even inbuilt injectors into the wing as engine create additional speed over the wing. The same so-called vortexing devices creating additional vortexes over the wing. However weird is it sound after what we have talked about, it's for tuburization of boundary layer over the wing, and due to this they create additional lift at the moments when they are working. Do imagine that somewhere in the upper surfaces of the wing you have outlets, and these outlets has tiny they create tiny jet streams over the wing during takeoff and landing, and that also effective way to solve problem with shortening runway. But you must understand, as usually you understand already everything, I hope, that as only we add some additional devices, it means that we overweight the structure of airplane. It will be heavier than structure without such devices. And it means that for cruise flight, it will be more effective. And it's necessary to keep balance whether you really need device of short takeoff and landing, where the short takeoff and landing devices are necessary. Above the all, it comes about non-prepared airplanes, non-prepared airfields, when you need to work in hard conditions, in maybe it's some place where you have not much space. Maybe it's some area where you have no ability to prepare big airplanes and to maintain these big airplanes, to forgive me, airfields, and maintain them. No, somewhere in polar area, for instance, or in desert area. And in such places, of course, you need no guaranteed. You need to guarantee that airplane take off safely and stop quicker in order not to meet any obstacle, in order not to have crash. Obstacle not compulsory that airplane will stick into with its nose. Obstacle may be immediately on runway. If some obstacle in the view of stone, the additional amount, something like little amount of snow or sand will be something like heap of snow or sand on the way. And in this case, it may be resulted in problems during landing and or takeoff, and even especially when it comes about the takeoff, any obstacle on runway and takeoff maybe it's not stopped but crashed. Well, don't mean to scare you again. You understood, I hope, that we may use additional tubalizations devices or devices for controlling the boundary layer in the wing. And of course there are special, as I'm already said you, special fowler flaps which, or even flaps with ejections of such decisions I will also have seen in different books. Flap which has a jet stream through the flap, for instance, in order to increase velocity over the wing. Well, let's come back. No, that one about aerodynamical characteristics, and let's come back to what I said, vertical takeoff and landing. And here is the great picture. Actually we will use both the place in a book and the colorful picture in the end, at the end of this book I propose you to use. What is so great in this diagram? No, I read in a book that this diagram was composed by company, you see, oh, not here, what, McDonnell Douglas, да? This diagram, this let's say summarizing of technical decision, it was developed by diagram by company of McDonnell Douglas in 17th already then, and already then it has got name wheel of misfortune. No, maybe you heard that in America and in other countries they have such a TV program, the wheel of fortune, when people in studio rotates it, wait, what is the prize or what is the challenge they need to solve. Doesn't matter. No, that one it's like a joke about wheel of misfortune. What is represented in this wheel of misfortune? Why it's called wheel of misfortune? Because practically all the concepts, all the airplanes, and you see here is, I hope you see clearly that it comes. No, it comes about some classification in the this cyclic diagram, circular one, but also each next place it's practically finished with particular name of the airplane. And these particular names, whether they represented here or not, these particular names, they been constructed, but either they been crashed or has faced some problem during the testing, even during the flight, first flight tests, or at least they've been after constructing and testing program, they have been no, like rejected for using because it was considered that they are not rational to be used. Well, once again, why we interested in takeoff and landing? We understand clearly, I hope, that when it comes about military airplanes, they are interested in short takeoff and landing because they interested in the hidden airfields, quite clear. Or moreover, it comes about what is it visible in this picture. It comes about the using the deck of air carrier, so-called aircraft carrier in the sea. And military, why they are interested in vertical takeoff and landing, it's without discussion at all. Why civilians may be interested in vertical takeoff and landing? Not the same. Somewhere unprepared airfields, some villages, or some mountain place between mountains where you have limited ability to use linear runway, and in this case, of course, better to use vertical takeoff for different purposes. Yes, it may be some rescue operation, it may be some medical problem, somewhere, and you need quick transportation of civilians. And what it was proposed, not like historically, what proposed as vertical takeoff and landing. No, besides of rotorcrafts, besides of the helicopters and gyrodynes, autogyre is not able to make vertical takeoff. I hope you do remember. Besides of this, there are so-called no. By the way, besides of this, somewhere it was given here. Okay, let's check it. What here is the special types and helicopters. What helicopters? You see it. Да. Besides of them, what was proposed? Well, people are inventory as no one, I would say, and besides of attempt to change the vector of thrust. Besides of attempt of placing additional engines which are directed immediately vertically, for instance, what what were the most popular decisions? The very first, maybe, or the very first, they are so-called tail seaters. I'll show you right now. I've seen it a second ago. Here is that one, tail seaters. Now, if it was necessary to take off vertically, and what should we do? Let's rotate the airplane vertically and start vertically as we may start, no, like rocket, for instance, start. Yes, but it will be quite normal. No, seems like normal because they look subnormal, those airplanes, and attempts of such airplanes. What here is typical tail seater immediately already on the cover, you see. And attempts of these airplanes been started already in 14 years of 20th century. Of course, quite clear that it's maybe used only for military purposes. While takeoff and what is the worst, while landing, pilot not see the place where it's trying to land. That is significant problem for piloting the airplane. And let's see some of them more closely. I will send you this book in case you will be interested. You will see in details what you'd like. No, in case you have time for this. I understand that you are all overloaded right now. Let me maybe to use. Here is beautiful. Да. As beautiful as I don't know. As weird as I don't know what. But pay attention. Very interesting moment shown how to place it vertically. For instance, when it was saved somewhere in hangar or maintenance or whatsoever, how to place it vertically. It's necessary to have special device to rotate it into this position. Next, how pilot may get to the cockpit. For instance, one more additional problem. Of course, it's quite clear that such concepts, it's a lot of them. Let's see. No, a lot, I mean, not three, more. We may try to find quickly airplane tail seaters in internet, and instead of I scroll this in front of you, a lot of different designs. Here is one more, Lockheed, you see. And here is what I did say already about how pilots should get to the cockpit. You see, the whole additional structure looks like a rocket launch at all in order to place pilot to this position. And moreover, pilot need lay down. No, do you imagine it? And you understand it. He need to get in the cockpit and lay down horizontally. Of course, it's extremely inconvenient, and mostly all these airplanes not been in Syria. Quite clear. There is another variant of it, not much different, да? But it's already able, at least it's able to land both horizontally and vertically. One more conveyor POGA parasite airplane. Very funny structure. No, its appearance funny. You understand what do I mean? On the airfield. And when we continue watching this photo, idea you have already understood. First idea is to rotate the whole airplane. No, of course, it's a period. It's too much. It's inconvenient. It's да, what problems they faced since the first testing already. By the word, what here it's to help our imagination. Here is transition from vertical flight to horizontal flight, and of course, on this modes, airplane is completely unstable and it's very dangerous moment of flight. And to repeat it each time during the flight, if this airplane will be for serious using, no, it's dreadful. And first idea was let's rotate the whole airplane, as I already said. No, doesn't work. No, inconvenient. It's work. Such airplanes been designed, constructed, tested, as you might see. But of course, they not been in use. They may be considered like experimental airplane, those tail seaters. Okay, if it doesn't work, let's do the next one. We have even seen it, and as far as I remember, I saw "Do kill me." It's not helicopter. No? By the word, the letter X in these designations, usually it means that it's experimental plane. No, these letters V, it's quite clear for everyone. I hope that it comes about the vertical takeoff and landing airplane. But letter X, it means that it was experimental and not serial airplane, certainly. Well, and let's come back. Let's come back to the book. What immediately at the top of this picture, it's represented so-called tilt prop. If we can't tilt all the airplane, we may tilt all the airplane, but as a period, it's not convenient for takeoff, landing, and it's not reliable during the flight. Okay, let's do the same, but not to the whole airplane. Let's do it either to the wing or to the prop immediately. And in this moment has appeared so-called tilt prop and tilt wing airplane, where they are same propulsion, tiltable mass flow, a lot of different, a great picture actually. It's detailized the classification in such a way that it's practical. Oh, here is, that one is more simple. In this case, you see it's more detailized, and it means that by that moment people have more weird ideas how to solve these problems. And now it's not already so by the moment of this diagram being created, you see it's already almost 20 years ago. For you, it's maybe the whole your life already. But by the moment of analyzing the data, it was already a reduced amount of technical decisions, and tilt wing and tilt prop, what here is, you see, they are around 15% of all the models that we might need. What is idea? I hope you already understood. Let's see examples. Once again, not tilt prop, we clearly see. In horizontal flight, it's use engine nacelle rotated like for the cruise flight. And while the takeoff and landing, it's work as practically it's work like as helicopter, and it may even hover such an airplane. Problem is once again that it's not reliable. It's overweighting the structure always. The same is with any additional device, including this swept geometry, the changeable geometry of the wing, and that is significantly overweight airplane, and for regular cruise operating, it's not feasible. It means that passengers need to pay additionally for this opportunity to take off and land vertically, and together with additional money, passenger will pay with additional fears, do forgive me, because once again, all these transitions modes, they are extremely unreliable. And among the airplanes that realize this decision, we might find what, for instance, you see one of those airplanes. It was designed in different countries. It was designed with different types of engines. Pay attention, it's not prop engine, it's jet engine. Or typically we see it's called tilt prop because typically they've been used for rather slow airplanes with turboprops or even just prop engines of another type. But here we see such a decision for normal jet engine, and that funny one we have already seen. There is the same, but no, it's already another concept. I said the same, it's not the same. That is tilt wing. Tilt wing, it means that not only props or engine nacelles rotates, but the whole wing rotates during takeoff, landing, and next in transition modes. No, that is even, as for me, it's even moderate for structure, and I would say that this one, they are even over heavier in contrary to the that one which are with tilt prop. And that is, you see, not a photo, but of course it's painting for with idea that such airplane may take off and land vertically. What this forgot what I mean to say. Wait a second. Doesn't matter. If I forget it, let it be. And the maybe only airplane of tilt prop and tilt wing airplanes, whatever structures they were. Again, it was some tens maybe of attempt to design such structures in different countries. I meant to say that I already said it yesterday. Those types of flying vehicles, they are called not airplanes, they are typically called convertiplanes. Convertiplanes, the name you might see, for instance, here, and no, that book is it's rather interesting with rather good English, but it's old. It's not so richly illustrated. Maybe for you it will be not so interesting to scroll. And this book is old, as I'm already said you. It's 15 or 17 years of 20th century, but also it contains a lot of interesting stories. And one of these stories, look at this. What do we see? It's passenger airplane, but of course it was not designed as that one. That one is just a concept. This concept, and I forgot to show you one more concept for STOL. Let me to show it right now until I didn't forget once again. No, you see, it's called artist conception for convertiplane passenger transport. No, once again, as passenger transport, all these convertiplanes, they are not rational, not feasible, as they have additional weight. They are overweighted. It means that they are eating more fuel. They are eating more fuel. Someone need to pay for this fuel, and this someone, of course, will be a passenger. And plus to this, all these transition modes, they are not reliable always. If no additional engines that guarantee additional engines, additional devices that guarantee that airplane maintains the flight, continues the flight while this transition mode. If all the engines or the whole wing rotated in the transition mode, it's extremely unreliable decision. And what I meant to show you, it's called distributed thrust. It's not for vertical takeoff and landing. It's for shortening takeoff and landing, and also some concepts, especially last 25 years, are developed. Seems like anecdote, No, this one, flying anecdote, with some dozens of engines which are hidden in the duct inside the wing, inside the, maybe it's canard stabilizer, maybe it should be set tandem wing. And here it's visible, it's called artist concept. It means that it's painted. It's just picture of artist. It's not real photo. And for this distributed, what here is distributed propulsion, already exist at least concept airplanes, models of them that already started. They already fly, but they are models, no? Like that one, for instance. You see, it's rather similar to what I have shown you, Dabra airplane, and that one, of course, is just RC model. In the best case, it's RC model, but at least this is already under the study. Now, quite clear that it does not come about so many engines of heavy type, for instance, here. It may be one engine and some transmission systems that operate, that transmit the energy rotation moment to this multiple fans or multiple probes, which are hidden in special ducts, and due to this it's increase the propulsion force, and due to deviation, you see, it's like the wing, which consists practically of these sections of engines or sections of ducts and engine ducts, and you see that wing with some deviation with respect to the horizontal or vertical position, and due to this we may imagine it somehow remind us a story about how to move helicopter front. No? If thrust will be directed with some angle, it means that its force decompose it to the lift and decompose it to the horizontal flight direction. That is idea of this shortening takeoff and landing. Whether it will be rotatable or not, tiltable or not, such a wing, no, I do not understand yet. Maybe it's necessary to study this question more, to read this question more, but at least I need you to know about these rather weird concepts, as for me. Well, let's come back here. Tilt wing, tilt probe, we have already seen. Now, again, it's appeared that they are not much effective, and the only airplane of convertiplane type that I know was in operating, and it's maybe still in operating, as far as I understand. It's V22 Osprey. You already have seen it in one of my photo. I shown it for its foldable screw. No, foldable prop. When they are at the, what here is something like this we have already seen. Now that is example of convertiplane, maybe the only convertiplane, maybe I'm mistaken, but as far as I know, once again, that the only convertiplane that really has been taken into serial production and into operating. It looks like somehow remind us huge helicopter in flight or a huge gyrodyne, but in contrary to gyrodyne, it has no permanent main rotor. It has only rotated, tilted engine nacelles with huge props, and these huge props necessary to create lift during takeoff and landing, and next they rotates to the position of cruise flight. What here is in transition mode, it's visible, and moreover at the land position, would do pay attention this photo, the whole wing may be rotated, but not for the flight purposes. It's rotated in order to create a compact structure of the whole machine, of the whole vehicle, and this compactness help them to hide this thing. Now, whether on airfield in special ailing, in special hangar, or immediately at the area aircraft carrier, immediately at the vehicle. Next, we have seen it already in a diagram. Так, get used or get lost, or we have no space at all in this window. No, here is also about tilt wing airplanes and list of tilted wing airplane. As I said you, it was not the only such airplane you see of different capacity, different weight, and do pay attention to the years of their developing. No, that is the last maybe. And I read about electric airplanes that trying to realize this concept of rotatable wing, of tilted wing, but do not remember them. Next, one more thing maybe rotated, not the probe as a whole or engine as a whole. You've seen that tilt probe, it means that the whole engine is rotated. But instead of rotating either the whole wing or the whole engine in a permanent position, and here is what Bell X-22A, we will try to find it immediately right now. In book, it's also represented. Just afraid to search for it. Sorry. Ой-ой-ой, Bell. No. Too much. Let's take a look once again. Bell X-22. Bell X English 22. I love you. Here is. Here is, we see this airplane. Do pay attention where the engines are. In this photo, it's extremely visible, extremely clearly visible. Engines are here, you see. It has, no, seems like it's tandem wing, or it's canard, or it's tandem wing in this case, because one wing is ahead of another in different heights. Whatsoever. What it has the probe. These probes, of course, they are related immediately, mechanically related to the engines, but engines are separately. Engines for cruise flight, they are separate, you see. And these probes, they are enclosed into special, into cylinders, into special ducts. On one hand, it helps you, do remember this story with turbofan engine, enclosing the probe inside the duct, it helps to reduce size of the probe with increasing the capacity of this probe simultaneously due to special inner channels in turbofan engine. Here is just ducted probe, and this ducted probe is rotated during the flight. For takeoff landing position, it will looks like this. Here it's visible. And for a cruise flight, it's looks like this, and additionally create the lift. Do pay attention. Additionally create the thrust, and additionally may create the lift if necessary. And do pay attention how insufficient the wing area with respect to the to the obvious gross weight, takeoff weight, and sizes of this airplane. No, whatsoever, as only once again we have some additional devices inside of structure of airplane, it will be overweighted. And here is, we see on one hand, look at this picture, Bell X-22 fans inside the ducts, which are rotatable, tiltable. And here is a very similar decision, what here it's shown in this picture. Vanguard omniplane. If possible to find it, what I'm quickly. I mean, what I doubt in. No. No, at least we see it. Instead, and some such structures, they are presented in the book. Will not scroll it right now. In case, once again, you're interested to see, you will find it. This airplanes of this type. And in this case, fan is already permanently in the same position. It's like not rotatable. It's permanently here, and engine joined to these fans. No, on one side, on one hand, engine may give normal cruise thrust, and additionally, it's may drive these fans, which are always in horizontal position, and these engines, not engines, but fans in horizontal position, they redirect thrust in order to have lift, additional lift during takeoff and landing. Uh, it was about changing the structure, the most of them, changing the structure in terms of rotating the whole pieces of structure. No, besides of tail seats, that tail seats that we have seen, funny creatures, and besides of vector thrust, and we are not talking already about rotor crafts like helicopters and autogyres. The tiltable structures of airplane. Look, tilt prop, tilt duct, tilt wing, tilt rotor. Да? What is the difference between tilt rotor and tilt prop? It's mostly comes about the proportions, and comes about different types of engine. What is also interesting, besides of this vector thrust, maybe additional engines inside of the aircraft. They have two groups of engines. No, in particular, that one. Look, lift plus cruise, or lift and lift cruise. Those things. It means that they have different engines for different purposes. Once again, one engine permanently on board that you not use during the cruise flight. Quite clear, it's bad decision for any civilian airplane, for any civil airplane. Additionally, what also may be what in terms of thrust vector control, either the whole exhaust channel is rotatable, or as we might have seen even in Yakovlev scheme, that it's additional fan hidden inside of the fuselage of the airplane, which is opened during takeoff landing, and it's besides of redirecting of vector thrust, it's a fan additionally, or it's maybe some, as it's called here, ejector, additional devices which not redirect the whole exhaust, the whole thrust, but they redirect the portion of exhaust in order to create the force directed vertically during takeoff and landing. Very interesting subject as for me, and variety of the structures, starting from short takeoff and landing. Short takeoff and landing, they are not even so various, I would say. It mostly comes about some tricks with high lift devices, like above all the powerful high lift devices, fuller flaps of some links, and with additional ejectors maybe to create additional downwash here during moment when you need to shorten in your runway. And when it comes about takeoff, especially because when it comes about landing, we have more opportunities to shorten the landing. Starting with this reversing of engine, air brakes, braking parachutes, and so on. Not for passenger aircraft, of course, these parachutes. Those things are well known. But for landing, of course, you are limited in abilities, let's say, and For civilian and cargo airplanes, mostly it comes about the perfectorizing of the airfoils of these highly devices, and about devices of boundary layer control. And boundary layer control may be also realized by different ways. I hope you already remember effect of calendar, using of jet stream of engines in that or another way. And it's also maybe additional using of additional devices which create turbulation zones instead of laminar zone, however weird it sounds, let's say. They create here is additional jet stream over the surface, and this little turbularizer, little vortex creator, they are hidden in the top area, in the top, under the top surface of the wing. And when it comes about the vertical takeoff and landing, if not helicopters, but another types of airplane, the fly of human fantasy you have already just seen. And very good book, I recommend you, in case you have time to use it, just to scroll it to see some places that may be interesting for you. Not right now, maybe. No, to be frank, some places in this book, they may be interested for you even now, because here is a lot of, not there, at the end, a lot of statistical data, including the analysis of weights that you need, for instance, for your design of airplane. Where is it? Or somewhere here already. No, it's necessary to find the proper place, of course. It's not about weight yet. Analysis of geometry, analysis of weight, some pages with tables. But more simple for you will be to use simple way, honest way to find 3-5 airplanes somewhere in reference books or in internet, maybe. Analysis of aerodynamics, as I already said you in this book. And in the place where it's discussed creating the fuselage, maybe takeoff loads, or fuselage sizing and design. In this place, maybe you find some useful information also for you. No, I tried to supply the same information for you already in slides that I proposed you to use for your preliminary zero iteration design of the airplane. If necessary, may open and refer to this book in some places, let's say. And propose you also to use this for just to inspire your interest, as I said you. It's just to scroll practically and to watch, just to watch pictures. I would say, I may say, by the word, that is very popular, not popular, but famous airplane, which is called a flying saucer. Maybe you heard about. What happened? What is the problem? It's decided not to work. Okay, hidden one. I will propose you this couple of books. When you have time, you may familiarize with the information in this book. For passing the test immediately, it's not much necessary for you. Maybe I just kill your interest right now once and forever, maybe, to this subject. But once again, to pass test, it's not necessary. But maybe you will be interested in your future life, in some moments of design decisions given in these books, and maybe somehow you will be interested in this subject. Different photos, different decisions, and I hope you already recognize them. Where is the tilt wing, where is the tilt prop, and so on. And where is the vector thrust? Will your highness work? Yes, it's working. No, that is the the general view of it, it was real vehicle and it's really fly. Here is the cockpit. You see there is a tail unit group. So it has front and it has rear fuselage. And altogether this scheme, as you might see, no, really it's like unknown flying vehicle, seems like. No, not so weird maybe as some design of tail seaters that we have seen today. Well, to forgive me, maybe I overloaded you with information again. No, seems like it's rather short this time, and I'm not extended the time as usually. Well, let's maybe stop on this. If only let's see some photos together and let's understand where they goes into the diagram. What here is the tilted wing, yes, in different places. Tilted wing, another model, another airplane. Tail seater. What happened here? No any visible devices, no? Seems like no any visible devices. But as only we see this, what we understand, it has inner fence hidden inside of structure. Inside of the fuselage, there are normal engines. So seems like they are normal, but it's redirect the thrust by using of additional devices. More probably, it comes about fans. Why I think it's not ejector, not some rotatable. Forgot how to say it in English. Something like cover with slots. No, not something like this, because I see opened ducts at the top. And if we is the Dassault Mirage French airplane, if we find it in internet, quite clear, it will be visible in a scheme that really it has hidden fans inside. Tilt probe that we have seen already with jet engines. That one. Certainly, it has devices to redirect the thrust engine, like it has, maybe it has additional engines or in this area something is visible, and lift engines and vector at right thrust main propulsion engines. Yes, it has additional engines to realize vertical takeoff, and thrust of main engines also may be redirected. That one, no, that is very famous airplane Yakovlev. Yakovlev, it's something that we have seen in a video. They use vector thrust and they use additional fans in the fuselage. What in a scheme, it's represented. It's for another model, but it's very similar. And finally, when it comes about a lot of military airplanes, they fighters especially, and especially sea fighters that basing on air carriers. A lot of them, mostly they use vector thrust, and mostly they use this vertical takeoff landing fans. No, and military airplane actually may afford using of extra engine. It will also be resulted in overweighting, in reducing of maneuverability. It doesn't come already super maneuverability already in this case, you understand, but it may afford it because military airplanes, they are for no, for short plane, for short flight, and quite clear that short flight, it's not they are not limited in money, let's say, in contrary to civilian airplanes. They not much think about money. That one also visible what is decision for realizing takeoff vertically using of additional devices inside the fuselage. Whilst normal engine is somewhere here, we see intake, we see exhaust channel, the open places in fuselage remind us that it's hidden place, and in this hidden place it's hidden the additional fan. No, rotor dynes we have seen yesterday, gyrodynes, not rotor dynes, sorry. It's the name of it, fairy rotodyne, but the type of them are gyrodynes. Again, that one realized and used, constructed and used those things you see. Harriers, well known. What else? McDonnell Douglas Harrier. Practically not more something interesting. There are half of book yet, but mostly it comes about, as I said, you decisions of controlling the. No, there are some decisions. It's maybe controlling the thrust of the same engines due to additional devices like vector thrust and like additional fans. It may be additional lifting engines. Also, a rather popular decision was that some engines work during takeoff, some engines work during cruise flight, or they may be combined. And in diagram, it was represented like lift plus lift cruise engine. And there are rotatable elements of the whole structure: tilted prop, tilted wing, tilted fan, and so on. No, and in some cases it was not tilted fan, but fan inbuilt permanently in the fuselage or inbuilt in the wing. And once again, remind you that all these spans for experimentally airplanes, they are necessary because at the time when these attempts, pay attention how it start. Yeah? That one, it start from the special support, might be, or may start really vertically. That all these things, they were necessary because even now, no any simulation, no any computer calculations not ensure complete understanding of flight dynamics of airplane, of some additional problems that may happen during the flight, and that is why compulsory whatever structure, whatever concept, even after very careful development and simulation in the modern computer by modern computer means, compulsory after it will be tested in series of flight tests in order to ensure that our calculations, our simulations, they coincide with reality. No, whatever I scroll, you see, practically it comes about the same technical decisions. And thank you to those who created this diagram. It's a little bit more complicated maybe, but what is great in the diagram that you might find particular, besides of classifications, was it represented here? Oh, I spoiled the place maybe. Besides of those classification, it's also, it was chapter 9, I do remember, and in appendices it was referring to the chapter 9. Oh, I jumped. Here is. No, but here is they are not colorful, and in appendices, the same diagram in appendix, it's colorful. Whatever decisions I said you, it's represented in the diagram with name of the airplane that realize that or another decision. Since old history up to the new structures like this one, you see. Well, no, however, mute Jamet, it was explanation. I hope you understand that a lot of unusual structures, a lot of no, various decisions of in design, in engine, in airplane design, structure of airplane, in engine design, uh, And all these attempts, they were necessary, in my opinion, but the most of them were unsuccessful. No, I hope anyway you will be interested in these stories about vertical takeoff and landing, and you certainly understand that modern industry and modern now tendency in aircraft manufacturing, or even not in aircraft manufacturing, in aircraft using, we have a lot of unmanned flying vehicles. They are called in English abbreviation UAV, unmanned aerial vehicles. And these unmanned aerial vehicles, in turn, they also may be of quite different schemes, quite different decisions. They may be similar to rotorcraft, they may be airplane-like vehicles. And for their takeoff and landing, maybe it's also important some decisions, some concepts that been used in full-scale airplanes, represented in this documentation, in this history. And at all, it's interesting to watch, to understand attempts of humanity as a whole, what they strive to in attempts to cover all the possible variants of takeoff and landing. And hope you also will be interested somehow in the subject of helicopters or such such flying vehicles, and maybe somehow it will be next developed by you and derived into new structures. No, idea was to make you familiar with different concepts of flying machine and with different approaches in aircraft design. The weirdest, no, not the weirdest yet. The weirdest maybe we will see later, but rather weird at least. See you next time to talk about next chapter of history.